Distillery, according to the one that you saw, the little one, because in distillation, it's there's a, I mean, the way that it works is very similar, but what we were able to do with the newer distilleries is just first of all be able to be more efficient, but also control the quality. Back in the days, it was really kind of the idea of extracting the oil from the plant, but now we also know how to make sure that we don't harm any molecules, that we do it a certain way, we have a certain quality of steam, which implies a quality of water and all of this. So you'll see kind of the evolution of distillation, back from just the one you saw that was really just we put water, we put plants, we heat everything, and we obtain some oil. But you would have hydrolyzation, you would have all sorts of problem with that oil, but it was still like good enough for the technology and quite actually smart. You've been to Young Living Distillery before. You've been to Young Living Distillery before. You've been. So you've been. So you four have never been to a distillery.
Yes.
So this distillery is actually very different from a lot of the other Young Living distilleries, and it's mostly because of those blue containers that we have here. And you'll understand that it's also because of the way that we work here in France. You'll understand with Benoit and all of that. But I'll start just with the process of distillation, which you all understand. We need water,
Plants.
plants, heat. Okay. And so we heat that water and we make steam and we steam the plants. Do you know why? Those who know shouldn't talk.
Because then you can separate. So they release the oil, no?
The crack.
They crack, not exactly, but not far actually. So inside of the plants and the lavender, the oil is in little pockets, and so it is closed. When you were in the field, you saw that dried lavender still on the plants, but you would crush and that smell would come out. Because if you were to cut lavender and leave it in the sun, the moisture, the water content in the plant would evaporate, but the oil is in those pockets and it would not escape. And so the process of distillation is actually trying to break the pockets to release the oil and obtain it. So technically, if we were to take plants and just squish them, we would by mechanical force,
yes.
we would break those pockets and we would release a little bit like a sponge. But it wouldn't be very effective. First of all, because if you take a wet towel and you take one end and I take one end and we try and squeeze that towel, at which point does the towel become dry again? It's almost impossible. So you would always leave oil, and we're talking so little amounts that we would lose a lot by just trying to press, a little bit like they do for olive oil or grapes or things like this. We'd lose too much with the finite amount that is in the plants, but we would also obtain other things, not essential oil. We'd obtain sugars that are contained in the plant. We'd obtain waxes that are in the plant, so it wouldn't also be the best process. So we needed something that would actually break the pockets, release the oil, and extract it. And steam is actually very interesting to do this. When you have steam that goes through the plant, the steam actually is able to go inside of the pockets, and when the steam comes in contact with another liquid, in this case essential oil, it vaporizes the oil. So the oil goes from a liquid to a vapor. And vapor takes much more space than liquid. So for water, I don't remember, it's 1,200 times the space. So 1 liter of water and 1 liter of steam. Steam takes 1,000 times more space than the water. So a pressure cooker, you have a lot of pressure. It's not because you have more water or something. No, you have just steam takes more space. So there's pressure within that. It's the same idea. When you turn a liquid to a vapor, it takes more space. And so when the steam touches the oil, it vaporizes the oil. And since it takes more space, it increases the pressure within each tiny little pockets, and each pocket breaks. Did I lose all of you, or am I good? No? So this is why steam is very efficient, because another thing that's important to know is that every essential oil is different, but essential oils have a boiling point that is much higher than the one of water. So what is the boiling point of water? 100 degrees at sea level, okay? So at 100 degrees, we know we have steam. Most essential oil, all of them varies depending on the molecules, but a lot of the essential oils we have a boiling point at 200 degrees. So if you take an essential oil, put it in a pan, turn on the heat, it'll have to reach almost 200 degrees before it starts bubbling and coming into a vapor by itself, okay? But if you were to try and vaporize the oil without steam, it means that the temperature inside of the container would have to reach the boiling point of that oil. And so we would have to be close to 200 degrees inside of our distilleries. But if you do that, first of all, it would demand more energy, but also it would really damage the essential oil. Because an essential oil is composed of an array of different molecules, and some are more volatile, some are heavier compounds. And altogether it is what we call an essential oil, and each essential oil has a boiling point. But in the process of reaching that boiling point, you would break down, modify, and damage a lot of the different lighter molecules and a lot of the molecules. So you would extract an oil, but it wouldn't smell good and it wouldn't be good. That means that technically, if you had a container, the plants, and you made a fire underneath and reached 200 degrees, all of the oils would vaporize, break the parquet, and extract themselves. You could, in technical terms, reach that, but you would have a really, really poor quality oil. Okay? So steam is a great process because steam can actually vaporize the essential oils at 100 degrees. And so much lower than their boiling point, but still capable of vaporizing. The example that I often use is when you fry something. Okay, you all know how to fry something. You heat vegetable oil, and when you heat vegetable, normally at 180 degree, you have a normal temperature for frying fries. Okay, so at 180 degree, you have nothing in your oil. What do you observe of the oil? Do you notice anything on the oil? You just put it, I don't know, sunflower seed oil. I chose one. Put it in a pan, put it on the fire, heat it up to 180 degrees.
Bubbles.
You see bubbles?
No, it's getting dark.
So you see nothing. You see nothing until you add food.
Yes.
At 180 degrees, you see nothing because the vegetable oil boiling point is much higher than 180 degrees. So the boiling point of that vegetable oil would be 300 degrees. So you see nothing. You have very hot oil, but you don't see bubbles, you don't see vapor, and it's not going to smell of fry or oil at all in your house. But as soon as you introduce food, you introduce something else, you introduce water. And at 180 degrees, the water goes poof, poof.
Yeah.
It turns into steam.
Yeah.
And steam has this effect, actually, any vapor has this effect that if it's in contact with another liquid, no matter the boiling point of that other liquid, it'll vaporize it. And so as soon as you introduce water inside that oil, the water vaporizes, and it vaporizes all of the oil that it's in contact with as well. And you're producing a really nice aroma of fry for your whole house.
Yeah.
It's a natural diffuser. But this is the same idea that we use for distillation. We send steam through the plants. The steam goes through the plant, vaporizes the oil, breaks the pockets, releases that oil, and then the steam and the oil are carried out and continuing on until we cool them down into a liquid state. And then we will have two things that are collected. We have the water that was steam, that now we call hydrolite if we distill the roots, the leaves, the trunk of the plant, or floor water if we distill flowers. And we call it not just water, we call it hydrolite and floor water or so forth, because the water contains essential oil in it. The first thing that the steam does when it actually vaporizes the oil, it, I lost the word. It saturates itself with essential oil. So if you boil water and you add salt, what happens to the salt?
Dissolves.
You know.
Okay, sorry.
it dissolves, right? The salt disappears. If you keep adding salt, at some point what happens? You've never done this, salted water? If you keep adding salt, the salt will dissolve, and at some point the water is saturated, and so the salt will be at the bottom and it will never dissolve anymore because the water basically is carrying as much salt as it can. It's exactly the same idea that is happening in there. The steam goes through the plant, vaporizes the oil, and it takes in all the oil that it can, and then when we cool everything back down, we're left with a water containing essential oil. So we're left with a floor water if it was a flower, or a hydrolyte if it was another part of the plant. And on top of that, all the salt left at the bottom that couldn't dissolve is what we would have as the oil that usually floats on top. Usually because most of our oils are lighter than the water. This is actually why we call this an oil. It is not an oil in the sense of olive oil or anything like this. It is just because it was lighter than water. But we do have some oils that are heavier. Or we do have some oils like rose that is the same density as water, which makes it very difficult to separate. But in most cases, lavender and all the plants we have here, they will actually come back to the surface and float on top of the floor water. Okay? So this is a little bit the process of distillation. It's actually not that difficult. But with those distillery and the modern ones that we have nowadays, we were able to really perfect basically every single measure or every single part of distillation, which gives us really a quality. So the first three things that we usually look at distillation is temperature, pressure, and time. The time you distill means how long does it take to extract all the oil in the plant. The temperature is the temperature of the steam. If you're too hot, you're going to damage the oil. If you're too cold, you're going to have water and not steam, and that's going to create an effect within the distillation process, which we call hydrolyzation. It's a hydrogen molecule that's separating within the water and assimilating to the oil. It's a complex thing, but basically it makes bad quality oil. So we don't want water, we want steam. But we don't want steam that's too hot or we damage the oil. And so that's temperature, time, and then pressure. Pressure is the same idea. Pressure could actually alterate the distillation, but pressure altogether would damage the oil. So inside those chambers, we're actually at the same pressure that we are right now. I always say pressure is something you can have at work, but here we have none. So the idea is that we do not want any pressure. I'm going to explain a little bit how this works, and you'll understand how I can tell you there's no pressure as well. So at this facility, this is where we would distill. This is where the plant is located. But there's not water at the bottom of this. The water in this goes into what we call a boiler that's going to produce steam that we will send inside of this. But this is very different than any of our other distilleries at Young Living, because those are actually containers. Those containers, they hook up on the back of a truck, they are loaded on the back of the truck, and the truck brings them to the field. And we have 7 of them, so that we can have 5 being filled at different fields, being ready, and we can have 1 distilling and 1 ready to distill, because we have a very short window of time. As you saw, we've just barely been around. You saw our fields, you saw one field of Benoit. Benoit has fields that are much, much further, much, much bigger, and we have a lot of different farmers and a lot of different directions. And when the lavender is ready, we need to distill it. If we wait a couple days, the oil quality will change. So we need to be very efficient, and we have 1 month in total because of different elevations. We have 1 month in total to distill all of the lavender for the year. So this system allows us to be very efficient. We can have people in the fields that are loading those. We can have 1 distilling. As soon as it's finished, we can actually switch, start distilling the next one, take this one out, dump it, clean it, bring it to another field, go and pick a one, and it's ongoing all the time. So it's about efficiency because we work like a co-op and because we have fields that are far, a little bit in the middle of everywhere. If you look at a distillery like we have in Finca or in Mona, all of the fields are surrounding the distillery, It takes very little time to bring the plant material to the distillery, so they load directly in the distillery in those round cookers. So they load in the cooker, they step on it, they close, and they have a lot of different cookers, so it works fine. But for us, we needed a system that is more efficient within our time window.